Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 3-methylbutane, 2-ol, Me2CH, or Me, a secondary alcohol. Moving on to the next step. Al2O3 at high temperature causes dehydration of the alcohol to give an alkene. The alcohol Me2CH, or Me loses water. The major product, A, by Zaitsev's rule would be the more substituted alkene. Removing H from the Me2CH side gives 2-methyl but 2Na, Me2C is equal to CH, Me. However, there can also be a carbocation rearrangement. The secondary carbocation, Me2CH, CH plus, Me, can rearrange via hydride shift to give tertiary carbocation, Me2C plus, CH2, Me, which then loses a proton to give 2-methyl but 2Na, Me2C is equal to CH, Me, or 2-methyl but 1Na. The predominant alkene, A, formed is 2-methyl but 2Na, Me2C is equal to CH, Me, via the more stable tertiary carbocation after hydride shift. Moving on to the next step. High adds to 2-methyl but 2Na, Me2C is equal to CH, Me, following Markovnikov's rule. The H adds to the less substituted carbon, is equal to CH, Me side, i.e., the CH, and I adds to the more substituted carbon, the C Me2 side. This gives Me2C, I, CH2, Me. And for the final step, AgOH reacts with the alkyl iodide in a nucleophilic substitution, SN1 or SN2, replacing I with O. Me2C, I, CH2, Me plus AgOH Me2C, or CH2 Me plus AgI. Me2C, or CH2 Me, which is 2-methylbutane, 2-ol, a tertiary alcohol. This corresponds to option A. Why other options fail? Option B is the same as the starting alcohol, no net change, which is not the result of this sequence. Option C, Me CH, or CMe3 would require a different carbon skeleton rearrangement not consistent with this pathway. Option D, OCH2CH2, Me is a primary alcohol not consistent with Markovnikov addition to 2-methyl but 2Na. Therefore, the correct answer is A. Therefore, the correct answer is option A.